So welcome all of you for today's bootcamp. As I mentioned, I'm Sneha from the DevRel team. I also have Ashutosh with me. He's also from the DevRel team. We're joining in from Mumbai, and today we are going to completely dive in, and we'll be talking and completely diving into the world of tokens. So without wasting much time, I'm quickly going to get started off with tokens. Now, before that, so I can see someone's asking me in the chat channel. So yes, Ashutosh, if you could send them the link to the Bootcamp Corda app, which talks about tokens. So I'm going to use at the end of the session, we'll do a small demo and we'll write a small token Corda app. And I'm going to use basically this particular token Bootcamp Corda app, which Ashutosh will be sharing with you in the chat channel. So meanwhile, I do the introduction and we look at some theory. It'll be good if you guys can download this particular application and set up tokens on your system. So quickly getting started off, looking at the agenda, we'll talk about the token evolution, and then we'll jump and talk about the token SDK in Corda. We'll also talk about the token taxonomy, which talks about how tokens are usually classified in Corda. And then we'll jump into and look at the Token SDK library, which provides you with certain classes which you can build when you can use, which you can use when using Corda Token SDK, basically when building a Token SDK Corda app. And lastly, finally, we'll wrap up this session by writing a small token Corda app. Okay. And I'll also talk about certification at the end. Okay, so let's take a look at the token evolution. So starting right from the very beginning, from the very first token, which was created, which was the Bitcoin. So we can say that the blockchain buzz started off in 2009 with Satoshi publishing his first white paper where he spoke about Bitcoin, right? And then in around 2011, there were altcoins. So as Bitcoin code was open source, anyone could actually take and tweak the code and launch their own coin. And that's how altcoins were generated. Then around 2015-ish, we had basically Ethereum. Yeah. So, yeah, sorry. So around 2015, we had the Ethereum buzz, which basically extended the concept of Bitcoin, of decentralized storage to decentralized compute. And I would say smart contracts were quite born at that point of time, or you could say reborn at that point of time. So looking at the advantages of blockchain, which Bitcoin offered to the users, we at R3 and all of us, basically, we started thinking of how this very concept can be applied to enterprise applications. So can we in any way make use of this technology in a regulated way? And that's where R3 and Corda were born. Now, before jumping on to the actual Token SDK Corda app, let's talk a bit about how Corda is different from a permissionless blockchain-based world or a system like Bitcoin. So typically in any permissionless blockchain-based system like Bitcoin, anyone can join the network. Any anonymous party can join the network. So in order to validate the transactions are sent to all the parties in the network. Sorry. So because the information is sent to all the parties in the network, everyone has a copy of all the transactions in the system. And now to maintain a true ledger or one single source of truth or one single source of branch or one single source of blockchain branch, the majority of the network must be in consensus of this branch. Because of this, heavy proof of work consensus is required as the transactions are distributed to all the nodes within the network. And since data is distributed to everyone in the network, the consensus, it's really at the network level. And hence, you cannot achieve instant finality as you have to wait for confirmations from all the participants in the network, or basically you have to wait for certain X confirmations before your transaction is finalized. Also, the transactions are broadcasted to all the nodes on unencrypted channels. So in enterprise real-world business applications, you definitely need to think differently, right? And that's how Corda's architecture was completely modeled based off regulated enterprise financial needs. Now, with enterprise applications, you cannot have anonymous party. You need to know the parties whom you're transacting with. Now, in Corda, any random anonymous party cannot join the network. The parties need to undergo a certain KYC process before you join the network. Transactions of these regulated industries, they have sensitive data. And because of this, you cannot afford to broadcast the transaction to the entire network, right? You cannot afford to have these transactions replicated to all the parties in the network. And that's where Corda is different, I would say, where only the parties who are involved in the transaction get a copy of the data. And that's why we can say the communication is only point to point. And that's how, because of its unique architecture, privacy can easily be achieved. And hence, because now the data is not distributed to everyone in the network, you can say that the consensus really is not at a network level, and consensus is literally at a node level now. And because of this, heavy proof of work consensus is also not required. And again, now, because the communication is only point to point, finality can be instantaneous, and you do not have to wait for certain X confirmations before achieving finality. So that being said, now that we know what are the typical differences between Corda and a traditional permissionless network, so let's keep these differences in mind and let's move on. So this slide talks about how it all started off. So how it all started off with cryptocurrencies and how we got to regulated token offerings. So cryptocurrencies, I would say it really got us thinking about what is money or how does it work. It helped us understand the double spend problem. Smart contracts and Ethereum got us thinking about how business workflows can be automated, or how can multi-party computations be automated and guaranteed to perform, that too between untrusted parties. 2017, we had a lot of ICOs. And I think this got people thinking about tokens, or rather how tokens can be used more than just a currency. Can tokens be coded, and what kind of complex functionality can be added to tokens? We started thinking about all these things. Now, if we think of most of the assets in finance, most of the assets in finance are usually basically they're an agreement between an issuer and the holder. So usually there are these two parties, or basically sometimes there are more than two parties, and the agreement is usually a promise amongst two or more parties. And this promise essentially can be recorded as a token on the blockchain network. And this basically this is how we got this basically gets us to security token offering. So as an industry, we are now focusing on how to record this regulated financial asset on the ledger, which is the blockchain. We are now talking about automating the full entire life cycle of an asset. So when an asset is created, when an asset is moved around, how can we have a token which will work for this entire asset life cycle? Public markets, I would say they're fairly accessible, and they're quite automated and quite efficient. I think private markets are difficult because of regulations, and I think use of technology is also quite low at this point of time in private markets. And since typically any asset typically tends to sit as a PDF file on your computer. And these assets are also not easily accessible. You cannot easily trade them, exchange them, or move them. And I think that's where the opportunity lies. So any asset can be represented in any digital form, and essentially these are called as tokens. But unique thing of representing an asset on a DLT or a blockchain network is that you can program these tokens. So you can think of tokens in many ways. The access rights of a token or an asset can be programmed in a token or in a smart contract. Hence, an asset can be completely automated. Its life cycle can be completely automated using a token on a DLT ledger. Now, a token, I would say, does not represent a digital file that is sent from one device to another. Instead, it refers to the access rights that are collectively managed by a network of computers, which is basically the blockchain network. Now, tokens can represent anything from a store of value to a set of permissions in the physical, digital, or legal world. They can also incentivize an anonymous or basically an autonomous group of people to individually contribute to a collective goal, something which Bitcoin does. So with tokens, we are now able to have something like the fractional ownership, which you can see in the diagram of, let's say, an art or real estate. This might improve liquidity and transparency for these kind of illiquid assets. Now, Corda nodes can exchange tokens directly without any intermediaries, allowing transaction to take place globally 24/7. And hence, I would say, reduced minimum investment and periods open up investment to a much wider audience. Now, tokens can easily be moved from one exchange to another exchange, making secondary trading again very easier. Now, time-consuming parts of the exchange process can be completely automated through the use of Corda contract verification as well. Now, let's dive a little bit more into Token SDK. Now, Corda currently supports the creation of tokens using Token SDK. Ethereum produced the ERC20 technical standard for implementing fungible tokens on the Ethereum blockchain. Ethereum also has the ERC721 standards, which defines the standard to define a non-fungible token. Now, this amounts to a basic interface definition, but it allowed exchanges to handle arbitrary token types defined on the Ethereum blockchain, as all of them, they shared the same interface. It defines basically these standards, they define different functions, like it helps you to know how, what's the total supply of the tokens, or rather what's the balance of a particular address, or basically it provides you with interface of functions about how you can transfer tokens. So there are a lot of ERC20 compatible tokens found on Ethereum as of now. So all of these tokens will have a shared list of rules they all follow, allowing developers to accurately predict the interaction between these tokens, including how they are issued, transferred, and how data can be accessed within them. So I would say Token SDK does for Corda what ERC20 standards or ERC721 standard does for Ethereum. Of course, there are certain additional functionalities which we have added in Corda Token SDK, but essentially it's something similar to ERC720 and ERC20 standards, basically the standards which represent the fungible and non-fungible token standards. So now what is the token in Corda? So a token, I would say, okay, guys, any questions? If you have, keep on dumping them in the chat channel. Ashutosh is there to help you out, and I'll also take a look at them in some time. So a token represents an agreement between an issuer and a holder. Now the token is a liability, I would say, from the issuer perspective, and an asset from the holder perspective. You can think of tokens in this way. So everything in Corda, you can assume it to be an agreement. So tokens actually represent an agreement between an issuer and the owner. So basically, because of this, it's an asset from the holder's perspective and a liability from the issuer's perspective. So hence, in a nutshell, you can say that a token is an agreement which is issued on a blockchain network. And since it is issued on a blockchain network, all the parties which are involved in this agreement, they're aware of this agreement. And these parties can define certain rules on this agreement. And this agreement or this contract is a self-executing agreement which runs against these rules, which are defined by the participants on this blockchain network. So now let's take a look at the token taxonomy. Now, Corda's token SDK model, I would say it's flexible enough to accommodate any type of underlying thing in question, and it helps tokenize it easily. It has a set of interfaces, flows, abstract classes, which again, as I mentioned, they're analogous to ERC20 and ERC721 standards for fungible and non-fungible tokens. Now in Corda, when we look at tokenizing an asset, we have to look at two things. First, we talk about what needs to be tokenized. So here you talk about the underlying asset. Now, once you start talking about the underlying asset, this underlying asset can exist either off ledger or it can actually exist on the ledger. So when I say off ledger, I mean, let's say you have a house or you have a commodity like gold. And so these kind of assets, they exist off ledger and you wish to tokenize them. The other part is the asset can actually exist on ledger itself. So basically, let's say that you can have an equity which is issued on the blockchain ledger directly. So you don't actually have a physical asset in the real world, but rather the asset which you want to tokenize exists on the ledger itself. So so you basically, you can have equity or basically a bond or any derivative instrument. These kind of assets tend to actually exist on the ledger itself rather than existing in real world as physical assets. So again, to repeat, once you decide to tokenize your asset, you should know whether the asset exists off ledger or on ledger. Okay. Now, once you know what your underlying asset is going to be, then you can go ahead and then you can issue tokens on top of this underlying asset. Now, to issue tokens on this underlying asset, again, the tokens can be either you can issue fungible tokens or non-fungible tokens based on this underlying asset. Now, if you look into this diagram will help you classify your asset so that it can be easily tokenized. So if you look into this diagram, it's basically on the horizontal axis. It talks about two things. It talks about classifying your assets into asset-like things and contract-like things. So there are usually these physical things in real life. So let's say that you have a commodity like gold, or you have real estate, or you have art. So these kind of assets, they exist in real world, and you wish to tokenize them. So these fall under this category, which are asset-like things. And then, as I mentioned, you have the contract-like things, which essentially they don't exist actually in a physical way in real world, but you can issue them on the ledger. So basically, any equity, or you can have an equity in, of course, in real life as well. Let's say you have an equity written on a document, but you can issue equity directly on the ledger as well. So any basically derivative instrument, you can think of any derivative instrument to be an on ledger asset. Now, once you decide what your asset is, then look at the vertical columns and then try to see whether the asset basically if the asset can be directly issued on ledger, in which case it's a native token, and check if the asset exists somewhere outside in the real world and you want to issue a depository receipt on the ledger. Now, once you decide these things, then you come to tokens, and then you start talking about tokens, where you say that, okay, this is my underlying asset, and now I want to issue, let's say, tokens on it. Then you start talking about these vertical columns where you say whether I want to issue fungible token or I want to issue a non-fungible token. Will my token be redeemable? And ultimately, if I issue tokens, who will be liable for these particular tokens? So when I say liable, I mean that so let's take an example. When a CBDC is issued by central bank, then the central bank holds the ultimate financial obligation, and that's how you know that ultimately the liability for this particular token is going to be central bank. So all of this completely, it depends upon your use case. So make sure that once you decide to tokenize your asset, look at this particular token taxonomy. It's going to really be helpful in it will help you to tokenize your assets in a better way. Now, we saw that the underlying thing, which is the asset, can exist off ledger or it can exist on ledger. Now, when defining this underlying asset or when defining this underlying token type, we also consider one more aspect. We consider whether this underlying asset is fixed or it's evolvable. That is, whether this asset can change over time, or the asset is fixed. That is, its properties are fixed and the asset will not change over time. Okay. So depending upon if the asset is fixed or it can change, you depending on that, you either subclass your asset class directly from the token type interface, or you use evolvable token type interface. So there are two ways in which you can define your base underlying token type. You can either subclass it using token type if your asset is fixed. If you think your asset might change over time and you want to make sure that you track all of these changes, you use the evolvable token type. Now, when you subclass using token type, usually token type has got two fields. It has you need to specify your token identifier, and you also need to specify the fraction digits. So for example, if you want to define a USD token type, so let's say that you want to issue some tokens and your base token type, let's say, is USD. Okay. So in this particular situation, this basically is a currency token type, right? And let's say the identifier will now be, let's say, a string USD. And let's say that the fraction digits is 2. So that's because the smallest denomination is 1 cent, which is, so basically 1 cent is 0.01 USD. So that's how USD, which is kind of a fixed base asset type, you can define that using the token type interface. Now, this talks about the evolvable token type interface, which we already spoke about, right? So you can use the evolvable token type interface to create the underlying asset if you think the asset might change over time. So let us consider using evolvable token type to represent a car, for example. So a car might have price or mileage, which can change over time. And using evolvable token type, which ultimately internally it's a linear state, and that's why it helps you track the latest current version of the token state. So basically, you can represent a car, which is an evolvable token, which is an evolvable asset. You can represent that using an evolvable token type interface. So a quick recap, we just saw that there are two ways in which you can represent any asset. First, you need to see if it's fixed or evolvable. If it's fixed, then you subclass it using a particular interface, which is the token type. If it's evolvable, you subclass it using evolvable token type interface. That's it. That's really it. Now, now let's talk about how you can issue fungible and non-fungible tokens on this asset. So we've already seen how to define the base asset type. So once we've defined the base asset type, now let's go one step further. And now let's define tokens based on this underlying asset. Now, bear in mind, we already spoke about this, that a token is always an agreement between the issuer and the current holder. And hence, the fungible token class is for handling the issuer and the holder relationship for fungible tokens. So all token types, basically, they are wrapped in an issued token type class, which helps you define who the issuer is for this particular token. The amount basically signifies the amount of the fungible tokens. Again, please note that the tokens with the same token type, but different issuers, are considered completely different and it cannot be mixed. So let's say that you have two token types. So let's say that you define tokens and you define two fungible tokens, and both of them, they have been derived from the base token type, which is the car. Okay, so you're trying to define fungible tokens based on a car token type. Now, if both of these cars, they have different issuers, then you will not be able to merge these two tokens because the issuers are completely different. So let's say that one is BMW and one is Mercedes. So you do not want to mix these kind of tokens where issuers are different. So that's about it really from a fungible token perspective. So if you want to define a fungible token, you need to know who the issuer is. You need to know how many fungible tokens you want to issue. And then you need to know what kind of asset is I want to define tokens on. So that's the token type, which tells you what's the base token type. Now that's the fungible token. In this diagram, it shows you that fungible tokens can be split and merged, meaning that the quantity can be split to produce multiple tokens, or they can be merged together to produce one or more multiple tokens. But again, keep this in mind that again, splitting and merging is possible only if the issuer is same. Now, non-fungible token, which is an NFT, also defines a relationship between the issuer and the holder, but it cannot be split or merged. And of course, it doesn't have a quantity, or rather, you can say it always has a quantity of exactly one, because it's kind of unique. So a house can be a good example of non-fungible token. Now, again, mind you, just because something is non-fungible in real life doesn't mean that you have to treat it as a non-fungible token on Ledger. It completely depends on your use case. So basically, we have already spoken about this. There are two things. First, define the token type, the underlying token type. Once you have the token type, decide what kind of token you want to issue or based off this token type. So just because the house is is non-fungible in real life, this doesn't mean that you can't define fungible tokens based off this house. So for instance, a house is something non-fungible, right? So you can't physically split a house. So, but let's say that you have a Corda app where several people can invest and buy one property, and then they rent it out and split the return on their investment. So for this, what you can do is you can create a token type, a base token type called as of house, and then you can issue several fungible token instances of the same house, where the quantity of each token is different and it represents the ownership share of the holder in that house. So this way, anyone can sell their share to multiple buyers or buy from multiple sellers, which in Corda will be splitting and merging the fungible token of the house token type. So that's about really it from a Corda token SDK perspective. So you have you have ways to define the underlying base token type. So you can either use the fixed token type or evolvable token type, or once you're done with that, you go ahead and issue either fungible or non-fungible tokens. Now we saw how we can use the evolvable token type to define an asset which changes over time, right? We've also seen how to define tokens on top of this, which can be basically fungible or non-fungible token. Now, when it comes to linking them together, so basically embedding a state directly in a non-fungible token or a fungible token state doesn't make sense, right? Because let's say that you would have to perform a token update to change the underlying token type. So let's say that let's say that you have a car token type, and let's say that this particular car base, your base asset, changes over time. And if you embed this object into the token itself, the token will also have to change, right? And that's why there's this concept of token pointer. And that's why it makes more sense to include a token pointer of a particular token type inside the token. And that's what token pointer is really all about. So this way, what happens is your token and your basically token and your underlying asset type, they can independently evolve. Now there are different inbuilt flows which can be used to create the asset types on the ledger, and also to create the fungible and non-fungible tokens on the ledger. Then there are also flows which you can use to move around tokens from one party to the other party. So we will see how to use all of this in some time now. Okay, now let's directly jump into the code. So Ashutosh, can you share the link again to the Bootcamp Corda app? So guys, all of you, please open your idea, IntelliJ idea. And I'm going to share my IntelliJ idea now. Yeah, here you go. So I'd love to work with you on this particular sample. Okay. So let's get started with this particular a simple token SDK sample. Yeah. So basically what I've done is I've modified our typical Bootcamp Corda app, and I've modified it to use the Token SDK, basically. So what you can do is you can clone the same from the GitHub repo. Ashu has already posted the link in the chat channel. Now, if you look at the project structure actually remains the same. We have a contract module, and then we have a workflow module. Now, let's begin by looking at the build.gradle. So for this particular sample, I'm going to use Token SDK version 1.2 and Corda version 4.8.5. So to actually import the Token SDK into your application, you just have to mention these two dependencies, which is the token contracts and the token workflows. Once you have defined these dependencies, just do a Gradle refresh, and that will pull all of the required dependencies for you for this particular Bootcamp Corda app. Now for this application or this sample, I'm going to use these 4 nodes. One is the notary, one is party A, party B, and party C. Now for this particular sample, we will see how to create the base asset type on the ledger. And then once we've created the base asset type, we'll see how you can issue fungible and non-fungible tokens based off this base asset type. Now to do that, let's quickly jump into the state class. Now, as we've already discussed, before even defining the tokens, you have to first define the underlying base type, right? So ideally, so this is my state token type, which is my base token type, which I've defined using this class. So I think that this particular asset is going to evolve with time, and that's why I've extended this using the evolvable token type interface or evolvable token type class. Now, this evolvable token type class, this has few fields which I've overridden over here. So, so basically it has the fraction digits, which lets you specify the number of fraction digits allowable for this particular token type. So usually for a currency, let's say USD, I would rather, I would actually give, let's say 2 fraction digits, so that let's say I'm able to, represent it in a better way. Now this is the maintainer field. The maintainer, I would say it's the party which actually creates this base asset type. And it's probably mostly the issuer of this token type, but not necessarily be, because many a times it also happens that there are certain reference data maintainers who actually are take up the responsibility of maintaining this base asset type, and they're completely different from the issuers. So this is the maintainers, and basically by default maintainers are the participants for this particular state, and they will be notified of any state changes. And then of course, as I mentioned, that the evolvable token type is internally basically a linear state, and that's where we have the linear ID, which simplifies the job of tracking the current version of your latest evolvable state. So this will always give you the latest evolvable state. And that's why these are the 3 things. Again, these are completely handled for you. And this is one extra property which I've added to this particular base type. So I've given it a name called as important information that might change. So for this token type, I think that this is the property which might change, and I want to really track this. So that's how I've added these properties as a property in this particular state class. Now, if you try to imagine how you can write a car base type, how you can define a car base type, you will do something similar. So instead of saying a state token type, you will say a car token type, which extends an evolvable token type. And instead of this particular property, let's say you will have price or mileage, where let's say the price will depreciate over time, and you may want to track that. And you may want to define this car token type as an evolvable token type, which is the base token type. Okay. So now I have defined my state token type over here. Now let's look into the contract code. Now this particular state, the asset type or the evolution of this particular asset is governed by a particular contract. Now this particular contract, it extends the evolvable token contract, and evolvable and inside the evolvable token contract, basically this class, it verifies and runs certain validations when issuing or updating the state. So you can of course add certain more validations if you wish so in the contract, in your contract class, but basically most of the work is already handled by you by the evolvable token contract class. So we have defined our state. We have seen how you can write more validations in this particular state token type contract. Now let's jump onto the flows now. So for this particular sample, I've defined 2 flows. So this particular flow, it basically lets you issue. So basically, we'll see how you can issue a non-fungible token. But before issuing a non-fungible token, we'll have to create a base underlying asset, right? So we'll create our state token type asset on Ledger. We'll see how you can create this asset on Ledger. And then we'll also see how you can create and issue tokens based off this asset. And then there's one more flow, where I will basically define a base token type. And now the base token type over here, we will see how to define a fixed base token type. And once you've defined a fixed base token type, we'll see how you can issue fungible tokens on top of this base token type. So let's start with modifying this code. And the very first thing is I'm going to call an inbuilt flow called as the create evolvable tokens flow. And I'm going to pass it to the subflow. And this create evolvable tokens flow basically, it basically help it basically it's an inbuilt flow, and it'll automatically create a base token type for you. So what we want to create, we want to create an evolvable token type, and our token type is state token type. So let's wrap this up in a transaction state. So let's wrap this up in a transaction state, and let's pass in what notary to use. Okay, so that's really it. So to create any base token type, you use the create evolvable tokens class or the flow, and you have already defined an instance of your state token type. So state token type, you've already defined a state. Once you've defined the state, you get the instance and you pass in this instance to the create evolvable token flow. So running this flow will create basically a base token type on your ledger. Once we have created this base token type, let's issue a non-fungible token on top of this base token type. Now, to issue a non-fungible token on this base token type, let's first retrieve this particular state from the database, which we just created using the create evolvable token flow. And we will retrieve it using, again, the query criterias. So you basically pass in a query, you pass in the UUID, that is basically an identifier or the linear ID, you can say. You pass in the linear ID, you get the state. And once you have the state, you simply use the non-fungible token builder class. So we have a non-fungible token builder class, which can be used to define or to get an instance of a non-fungible token. So as I mentioned, you always need to specify who the issuer will be for this particular token. So the issuer is me. So let's say if I'm running this flow from party A side, so party A will be the issuer. And let's say that I want this token to be issued to, or this token will be held by the recipient. So recipient is something which I'll retrieve, I'll pass into the flow, and I'll pass it to the held by method over here. And then finally, once we know who the issuer is, finally, once we know who the current holder is, I will simply, we also need to tell the builder what kind of token or what's the base token type for this particular token. And my base token type is the state. As I mentioned, we need to specify the pointer, and we do not wish to embed the state directly. We wish to embed the pointer inside the token. And that's really it. These are the three things which you have to provide. So you have to specify who's the issuer is, who is the current holder, and what kind of token this is. So for that, we specify the base token type. Once you've done this, I simply call the build non-fungible token, and that will give you a non-fungible token to you. Now, once I have this non-fungible token, again, I'm going to simply call a flow, which is the issue tokens flow. And you just have to pass in the non-fungible token to it, and all of it is handled. Basically, issuing the token is completely taken care by this issue tokens flow. So that was really it about how to create a base evolvable token type and how to issue tokens, or how to issue a non-fungible token on this base evolvable token type. Now let's move on to the next flow. So I'm going to put this in the chat. No, I think it's already there in the code. So let's move on to the next part, which is the create and issue fixed token type. Now over here, let's see how we can issue a fungible token on a fixed underlying token type. Now let's take an example that let's take currency as an R underlying asset. And there are three utility classes which you can use, which let you define and create these base currency classes. So let's get an instance of currency token type, and let's create a fungible token based off it. So these are the utility classes which directly, so here you saw, right? We used the create evolvable token flow, which actually creates the base token type. But if you want to create a fixed currency based token type, you can directly use these inbuilt classes, which gives you directly an instance of the base token type. So let's say that you want to issue certain tokens, certain fungible tokens on this USD. So you can directly use the money utilities.get USD or get AUD to get the base token type instance. You can also use the fiat currency, which again, let's say you want to have GBP as your base token type. You can use this inbuilt utilities. You can also use this digital currency class, which let's say gives you instances of, let's say, XRP, Bitcoin, Ethereum, and so on. So once we have the token type, the next part is very simple. You just go ahead and again use the fungible token builder, to issue fungible tokens. Now this is going to be similar to the non-fungible token. It's just that we need to specify the amount as well. So let's specify that this I want to create this fungible token based off this particular token type, and this is going to be my issuer, which is going to be me, and this is going to be my current holder, which is going to be the recipient, which I'm going to pass when I run this flow. And then finally, we also tell him that this is the amount I wish these many amount of fungible tokens need to be issued. And then finally, I say that build the fungible token. So now we have the fungible token instance. Now we call the same issue tokens class, and we pass it the fungible token instance. That's really it. So this is how you basically you define a base type, you get an instance of the base type, and then based on the base type, you define fungible tokens on top of it. So I think that was really it. And let's do one thing now. Let's quickly run this Bootcamp Corda app. Now to run this Bootcamp Corda app, what I'm going to do is I'm going to do a /gradle w clean and deploy nodes. So this basically, this command, it will deploy the 4 nodes which we have defined in our build.gradle. And so it will deploy party A, B, C, and notary. And once we're done with that, what we'll do is we will issue tokens. We will first, we will run both these flows from party A terminal, and then let's see what happens. So meanwhile, this basically runs. So this is trying to set up a local network. This is setting up a local network and starting off party A, B, C, and notary. So meanwhile, this starts off quickly again. What we did in this particular flow was, so for the create and issue evolvable token, we first defined the base underlying asset. Over here, we saw how to create the base underlying asset, which is evolvable. Once we did that, we moved ahead and we issued non-fungible token on top of this base asset. A non-fungible token is a token which doesn't have a quantity field. And we created this non-fungible token using the token builder. You have to specify who the issuer is, who is the current holder, and what's the token type of this particular token. And again, over here, we did the same thing. It's just that the base token type was fixed. It was not evolvable. And then we issued fungible tokens instead of non-fungible tokens on top of this base fixed token. And then we call certain inbuilt flows to do what we really want to do all of this, basically. So I think the bootstrapping is almost complete. So now what I'm going to do is I'm going to start off these nodes. Okay. Okay. So meanwhile, okay, this is done. So what happens is basically our network is already deployed locally. And now let's go to the deployed network in the nodes folder. So these are our nodes which are deployed in the network. And now then let's do one thing. Let's fire the run node command, which will start off the nodes in the terminal. So this is my terminal. Notary starting, party C is starting, and party B is starting. Okay. Okay, so the nodes are up. So let's do one thing. Now let's run our first flow. Let me go to the README and let me just grab in the command. So I'm going to copy the first command. And what we are going to do is we are going to first run the second flow. So from B terminal, I'm going to create an issue fixed token um, to party C. Okay. Yeah, the flow is completed. So what we'll do is let's fire and see if fungible token has been created on party C side. So this is the fungible token which has been created. And if you see, the amount is 100 and the underlying token type is GBP. And this has been issued by party B. And the current holder is party C. So these are the different things which you can see on party C side. Now let's move on and run the first flow. So let's first create the evolvable token type base type on the party B side. So the base type is created. Now let's run the vault query and see if our state token type is created. So this is my state token type. This is the important information that may change property which has been added. This is the ID. This is the UUID. And basically the maintainer is, as of now, it's party B. That is me. So now we have this. Now um, let's issue a non-fungible token from party B side to party C side. For that, let's specify the UUID. So I say that this is my base token type. Please issue a non-fungible token to party C. And the flow is completed. So now if you run and see the vault or the database of party C side, you would see that a non-fungible token has been issued to party C, the current where the current holder is party C, the issuer is party B, and we have a pointer which is embedded, and it's of a particular state token type, and basically this is the UUID. Yeah, I think that's about it from a code perspective. So let me share my screen again. Yeah. So guys, feel free to try. There are a lot of samples based on this token SDK. So there is Java version, there is Kotlin version. So go onto these links. So Ashutosh, if you could share all these links in the chat channel, that will be great. So Corda token SDK is completely open source. So I would urge all of you to go and clone this repository, try it out at your end. We would love to listen to your feedback, and feel free to put in any bugs or features request which you wish onto the token SDK sample repo, the GitHub repo basically. This is the documentation side. We have our developer portal as well, where we usually have lots of discussions around token SDK. And then, of course, we have our Slack channel where I would suggest, guys, all of you, please join. Because we have our entire engineering team, the developer relations team, all of them are available over there. So feel free to join and ask any questions at any point of time. You can directly ping me. You can directly ping Ashutosh as well if required. Now the interesting part. Yeah, so certification, we have different certifications available. As part of our bootcamp initiatives, we plan to give you the certification free of cost today. So Ashutosh, if you could please put in the chat channel the link to the free certification. So guys, if you could use this certification link, and it has a discount code to it. So if you can once you directly go to the link, you'll be able to take this certification free of cost. Again, feel free to reach out to me, to Ashutosh, to the Devrel team if you have any concerns while taking up the certifications. So I think that's about it. Thank you so much, all of you, for attending this session. I hope that you all were with me throughout. But for any questions, any queries, feel free to reach out to me at any point of time. And yeah, we'll be there. I'm going to keep this webinar on for another 3 minutes. So yeah, keep putting your questions in the chat channel. Thank you, guys. It was nice meeting all of you. Bye. Oh, yes, one thing. Please do share your feedback. The NPS link Ashutosh has already put in. So let's say that you do not want the introduction was like too much, or you want more of the coding sessions, or maybe you want to have boot camps or webinars based on certain different topic. So yeah, we'd love to listen to your suggestions. So please do vote so that we can help you out more. Thank you so much. And again, next week, Thursday, same time, office hours. So hope to catch most of you in the office hours. So go and try out the Token SDK. If you have any questions or any other questions as well, feel free to reach out to us on office hours as well next Thursday, same time. Okay, thank you. Bye. So the code is actually embedded in the link itself. So you go to the link and you just do a checkout, you'll be able to claim the free certification. Museum, if you have any concerns, do reach out to us. Okay, guys. Thank you. See you all soon. Bye.